Welcome to a new episode of Tech Stories by Techarc. Today, we are looking directly at the modern engineering constraints dictating smartphone design. The 2026 mid-range market is operating under strict realities. The rising costs of internal components, specifically RAM and solid-state storage, are forcing manufacturers to make brutal hardware trade-offs to keep retail prices intact. In our review of the Redmi Note 15 5G, we encountered a physical paradox. The device presents a Z height of 7.35 millimeters, a weight of 178 grams, and a 5,520 mAh capacity. Historically, accommodating this power requires a thick, heavy chassis to house larger cells. The Redmi Note 15 achieves this structure by abandoning brute force compute scaling in favor of high-efficiency component integration. There are two core drivers enabling this efficiency: silicon-carbon battery chemistry and the Snapdragon 6 Gen 3 system-on-chip. The system-on-chip, or SoC, is the central integrated circuit that houses the device's processor, graphics, and memory controllers. This architectural pivot moves the mid-range blueprint away from benchmark supremacy, directing resources toward physical and operational longevity. Designing for a 7.35mm profile introduces severe Z-axis constraints, leaving almost zero vertical clearance for internal power storage. This schematic compares the Z-axis cross-section. Traditional lithium-ion cells hit a volumetric ceiling. A standard 5,000 mAh battery physically spills past this 7.35mm chassis. Xiaomi resolves this with silicon-carbon technology. Its higher energy density packs a larger 5,520 mAh capacity into a thinner vertical space. This chart tracks battery health over charge cycles. The chemical degradation curve of this silicon-carbon cell remains flat. It is officially rated to endure 1,600 complete charge cycles before significant capacity loss. Mapping those cycles to daily use yields a projected 5-year healthy lifespan. This battery architecture pairs with an included 45-watt charging adapter, pulling the device to a full charge in roughly 1 hour. In 2026, achieving this slim profile requires a specific material science approach to resolve the historical physical paradox of high endurance inside a thin frame. The processor driving the system is the Snapdragon 6 Gen 3, fabricated on a highly efficient 4nm node. Looking at the benchmark reality, the chip yields AnTuTu scores in the 6.5 to 7.5 lakh range. AnTuTu is a standardized testing tool that grades the overall computational power of a smartphone. This scatter plot compares peak AnTuTu benchmark scores on the y-axis against sustained thermal stability across an x-axis of time. Raw benchmarking power is intentionally secondary to thermal management. The thermal stability line remains completely flat, hovering consistently at 90% even under sustained computational load. In a real-world application, this means the device locks demanding software, like the game BGMI, at a steady 60 frames per second without fluctuating. This tight thermal control directly relates to the chassis design. Preventing thermal throttling is critical to surviving inside a confined 7.35mm space, where heat cannot easily dissipate. Tightly controlling heat generation directly protects the internal battery chemistry from premature degradation. Sacrificing peak burst performance guarantees consistent daily operation. It protects the internal hardware from heat death over the device's multi-year lifespan. Transitioning to the exterior, the device utilizes a 6.77-inch 3D curved AMOLED panel, featuring cascading glass that wraps around the slim edges. The display pushes a maximum visibility threshold of 3,200 nits peak brightness, ensuring total legibility in direct outdoor sunlight. Integrated directly into the panel are specific eye care metrics, most notably 3,800 Hz PWM dimming. PWM, or pulse width modulation, is a technique that controls display brightness by rapidly turning pixels on and off. Operating at 3,800 Hz drastically reduces screen flicker and eye strain during low-light use, a metric backed by 2 Vrainland certifications. Transitioning to the rear of the device, the housing features a distinctive circular camera module. This module marks the global debut of the 108-megapixel Samsung HM9 sensor, equipped with optical image stabilization. Optical image stabilization physically moves the camera lens to compensate for hand jitters. Integrating this mechanical stabilization is a critical upgrade for mid-range optics, guaranteeing sharp images in motion or low light. The high megapixel count provides in-sensor 2x and 3x master pixel zoom. This crops into the center of the sensor, preserving optical-grade detail for portraits without requiring a dedicated telephoto lens. For video output, the hardware supports 4K recording at 30 frames per second. By securing high-end display and optical components, the device offers flagship-level content creation and consumption while strictly adhering to mid-range bill of materials, or BOM, constraints. Re-examining the 7.35mm profile, ultra-thin chassis designs inherently introduce structural flex and physical vulnerability. Xiaomi engineered specific physical countermeasures to prevent this bending. The chassis incorporates double-strengthened glass and an IP66 rating for complete dust and water protection. The frame also carries a MIL-standard 810H certification, validating its capacity to survive 1.7-meter drops onto hard surfaces. Moving from physical durability to software relevance, the device runs HyperOS 2, built on the Android 15 architecture. Combining military-grade drop protection with a committed roadmap of 4 years of OS updates and 6 years of security patches constructs a guaranteed 5-year operational lifecycle. Evaluating the complete hardware profile of the device and its standout mist purple finish brings the engineering decisions into focus. This infographic table displays the official market positioning. The device starts at an official price of 22,999 rupees, scaling down to an effective 19,999 rupees. Achieving this specific price point required deliberate architectural trade-offs. The main hardware concession is the inclusion of UFS 2.2 storage. UFS, or Universal Flash Storage, dictates the read and write speeds of the drive, and version 2.2 yields slower data transfers than some current market competitors. The physical expansion concession is the reliance on a hybrid SIM slot, removing the option for dedicated microSD storage expansion. The software concession is the continued presence of removable bloatware remaining active within the HyperOS ecosystem. These trade-offs must be weighed directly against the core engineering triumphs: the HM9 optics, the silicon-carbon energy density, and the thermal stability of the SoC. The final Techarc verdict is clear. The device operates as a highly balanced all-rounder. It is built for users who prioritize aesthetic quality and long-term reliability over peak gaming power. The Redmi Note 15 demonstrates that the mid-range sector in 2026 is maturing. Original equipment manufacturers can deliver highly stable, rigorously durable hardware without sacrificing a premium physical form factor to do it.